In this section, we're going to do a relatively more complex exercise. Hopefully, through this exercise, we can all get a better and more complete understanding of the various constraints we'll talk about, especially the aim constraint. So let's take a look at the scene together. This model is named Stewart platform. Let's quickly look at the behavior. Basically, we can translate and rotate this top platform. And we can rotate it in all dimensions. And all these connecting rods below will still stay perfectly connected and work together. I'd also encourage everyone to try rigging this on your own first, without watching the rest of the explanation. Based on the concepts and exercises we've covered, see if you can achieve the same behavior. The tricky part here is still what we talked about in the last section, using the different settings of the aim constraint to get the parts to interlock perfectly. I hope you can all figure it out. Next, let's start building this rig. When we're rigging something, we generally start with the simplest part. For this model, the simplest part is clearly this top platform. Here, we've already made some controllers using NURBS curves. Let's first look at our controller hierarchy. First, we have a blue controller. It uses the world origin as its pivot point to rotate. Underneath it, there's a green controller as its child. This one rotates around the center of our platform. Because these two have a parent relationship, when we rotate our blue controller, our green controller will follow. It will have a corresponding translate and rotate behavior. So here we actually just need to use the green controller and make a connection with our model, so that our model follows the green controller closely. This method we've also used it in previous exercises. With nothing selected in the scene, press Ctrl+G to create a group. Let's select our platform model and copy its name. Then paste it over. Since this group is for controlling our model, we'll change its type to trans. Then select our green controller. Select the group we just made. In constraint, find parent constraint. Let's turn off maintain offset here. Next, we just put our model into the corresponding group. If we look at our model's hierarchy, I've actually already created a group here and put all the upper platform parts into this group. So we just need to put this group under the group we just created. Because this is a parent constraint, we know that constraints operate based on world position. So it doesn't matter if we rotate the green controller or the blue controller. Both will affect our model. So now we've finished rigging the platform. Next, we need to do the slightly more complex part, which is the core of this rig, rigging these middle parts. Before we start, we need to look at their connection setup. We can see it's very repetitive. It's divided into 6 sections, and the part structure for each section is identical. Let's isolate one section and take a look. We can see that each section is actually a structure similar to a piston. When we go to rig these parts, we generally start with the main behavior, and then gradually move to the finer details, and rig those details. For this piston structure, what is its main behavior? Let's take a look. It's clearly divided into an upper and lower part. This upper part, it will always point at this bottom point. And this lower part, it will always point at this top point. From my description, I'm sure we can quickly think of the solution. Because they are pointing at each other's points, this must use an aim constraint. And our driver and driven objects are the pivot point positions of these upper and lower parts. So that's the main behavior. Next, let's look at the finer details, the individual structure of the upper and lower parts. Let's zoom in here so we can see it in more detail. I'm sure we're all very familiar with this structure. We did a similar exercise in the last section. This long rod is basically the arrow model we made in the last section. It's mainly responsible for the back and forth rotation, and our horizontal rotation is given to this base model to handle. The rigging logic here is to keep our aim constraints driver object's position and change the up reference object to achieve single axis rotation. As for how to rig this specific part, we've already done a corresponding exercise in the last section. It's really just 2 aim constraints. What we need to find here are the corresponding point positions for those 2 aim constraints. We know that for each aim constraint, we actually need 3 points. The driver object's point, the driven object, which is this part's own rotation pivot, and the up reference object's point. Let's first talk about this long part. Where is its driver object's point? Its driver object's point is clearly the rotation center of the lower part, and its own rotation center, which is the driven object's point. Where is that? That's also very easy to find. We can see there's a hinge here. We just need to find the center point of this pin, and that's our rotation center. Next, where is our up reference object's point? Let's draw this out together. We know our aim constraint's driver point is the lower part's rotation center, so the aim vector must point down in this direction. Then we know there's a rotation hinge here, so one axis must be pointing along it, and the last axis that will be pointing forward. Let's see, where is this forward position? It's also very easy to find. This forward position is actually the direction this face of this model is pointing. It's also the direction this face of the base is pointing. So here, if we can find a vertex on this base in this location, that's actually the point for our up reference object. Okay, so now look. We have the point for the up reference object. We have the rotation center, which is our driven object's point, and we have our driver object's point. This way, for this part's aim constraint, we'll find all three positions. We can now create an aim constraint for it. Next is our base, its rotation center. We can look at its structure. It's a cylinder, so it's the center point of this cylinder. Where is its aim constraint driver object's position? We know this base is always pointing forward, so its driver object's point is actually the up reference point from the previous part, and its up reference object's point was driving its rotation. It's driven by our upper part, so its up reference object's point is actually the driver point from our upper part. This way, if we look at this one section of our model, it has 6 sections. For each section, the point positions needed for the aim constraints. We now know how to find them. The next step is to actually find these positions in Maya and create the aim constraints we need. Okay, let's do this together. First, let's turn on wireframe on shaded. Then we create a locator and create a display layer. Give this layer a color so it's easier for everyone to see it in the scene. Let's start with the first section. We can see here its model index is 0001, so we'll start with this one. Since the rest are duplicates, we can look in a bit at how to duplicate it and adjust it to the other positions to quickly adapt it for our other models. Okay, let's start with the upper part. We have a rotation hinge here. Select our locator, hold V on the keyboard to snap it to its center. Then duplicate one and snap it to the other end. This way, we found the positions for both ends of this hinge. We'll duplicate one more. Use the tool we just created to point constrain the third one. This way, it snaps to the center position. This is the rotation center for this part. Let's copy its name and rename it. Its type is locator. And since it's not a model, we don't need the level of detail. In the description, we'll add aim pivot. Next is the aim constraint driver object's position. We analyzed this earlier. The driver object's position is the lower part's rotation center. So let's move to the lower part and take a look. The structure here is identical. So we'll use the two locators we just created, snap it over, duplicate, and do a point constraint. Change this to target. Next is our up reference object. The up reference object we also mentioned earlier is the position of this vertex on the base. So we'll duplicate one, snap it to this vertex position. And don't forget to rename. This way, all three locators needed for this part's aim constraint are set up. Next is our base. For the base, we know the previous part's up reference object is its aim constraint's driver object position, and the previous part's aim constraint driver position is its up reference object position, so we just need to find its rotation center. Let's isolate it. We can see its rotation center is just the center of this face on its base, so we'll duplicate one and snap it over, and don't forget to rename. This way, all our locator positions for the upper part are found. Next, let's find the locators for the lower part. First, its rotation center is actually the driver point from the upper part. Let's duplicate this locator's position and just change its name. Similarly, its driver object's position is the rotation center position of our upper part. So same thing, we duplicate one and change the name. Then the up reference object's position. We'll snap it over to this vertex position on the base. Finally, the rotation center of the base itself. This way, all the locator positions for this one part are found. Next, we can actually create the aim constraints. So here, we'll first copy the name of our up reference object. We'll need it in a moment. We select our driver object, select our rotation center. In constraint, find aim constraint. Paste the up reference object's name here. We'll just keep everything else as default. Then let's aim constraint the base. We know the base is the exact opposite. The upper part's driver object is the up reference object. So here, we'll copy the driver object's locator name. And the upper part's up reference object is the base's driver. So we select this locator, then select our base's rotation center locator. Then paste the name we just copied in here, and click Apply. This way, we have these two aim constraints. It's the same setup for the bottom. Let's do that too. And with that, our aim constraints are done. But there's one thing I don't personally like, which is that these locators, after making the aim constraint, have values in their rotation. In the initial state of our rig, when we haven't done any animation, I personally prefer all of these constraints can maintain a cleaner state for their translate, rotate, and scale, meaning all are at their default values. But right now, that's clearly not possible, because these locators need to point to these corresponding positions. So what can we do? We know translate, rotate, and scale. Their values are relative to their parent's coordinate system. Right now, their reference coordinate system is the world, because they don't have any parent object. But if we add a parent object, and this parent object has the same rotation as it currently does, couldn't we zero out its rotation values? Let's do it. Select nothing, press Ctrl+G to create an empty group. Then we'll copy the name over. Change the type from locator to 0. Because we're just using it to zero out the translate, rotate, and scale, we select this 0 group. Select the locator we just had. In Modify, find Match Transformations, match all transforms. This way, we'll match all its translate, rotate, and scale. Next, we put this locator under the 0 group. Now look, its translate, rotate, and scale are back to their defaults. Because the parent's coordinate system changed, in order for it to match the parent's coordinate system, it now goes back to its default values. This method is extremely common in rigging. For example, later we'll talk about creating controllers. To keep the controllers translate, rotate, and scale at their defaults, we'll do the same thing. Create a 0 group above it to change its coordinate position and the rotation. Okay, let's do the same thing for the other locators. This way, our locators are much cleaner. Next, let's create some model groups and parent constrain them to our locators. Then we can put our models into the corresponding groups. Select nothing, press Ctrl+G. Copy our locator name. Change the type to trans. And since it's a model, we need to add a level of detail. And use our locator to parent constrain. Next, we can put our models into the corresponding groups. This model goes under the upper part's rotation center model group. The base goes under the base's center point model group. Same logic for the lower part. Okay, so we put them into their corresponding groups. Next, let's move the controller. We'll see there's no effect. Why is that? It's because we haven't done anything to these locators yet. These locators are all at the word level right now. They aren't being affected by our controller. So now we need to analyze which locators should move along with our controller. Let's take a look. First is our upper rotation center. We can see it's clearly part of our upper platform because there's a connection here. So it definitely needs to follow our upper platform, which is our controller. Then there's our base's rotation center. It represents our base. Our base is also connected to the upper platform. So this locator also needs to be under the controller. Next is the up reference point for the upper part. It represents the vertex position on our base. It's also part of the base. So for the same reason, it needs to be under our controller. What else needs to be parented? The driver object point for our lower part, because it represents the same position as the upper part's rotation center. So these four need to be parented. The remaining locators, if we take a look, they represent this lower position. This lower position is not affected by the upper green controller, which is the platform. So we'll leave these in their current position. Let's find them. It's these two locators 0 groups, plus the up reference objects locator, plus the driver objects locator for the lower part. We select these four, then select the green controller and press P on the keyboard. This way, look, they are placed under the controller as its children. Now, when we move the controller, we'll see these parts start to have the corresponding effect. Okay, next, let's do some cleanup. This green controller, it already has 4 locators under it, and there are 4 locators outside it. If we look at our model structure, we know that it has 6 identical parts. That means we still need 5 more sets of upper locators. One part already has 4. When we add 5 more identical parts, we'll have 24 locators under this one controller. Similarly, we'll have 24 locators at the bottom. If we just scatter all these locators under the controller, it will be very difficult when we want to find them later. It will be a big hassle. So let's have a good habit. We need to organize them. This is just to make the outliner look cleaner and clearer, and make it easier for us to do more complex setup later. Here we select these 4 locators, press Ctrl+G on the keyboard, and we'll group them. Then let's rename it. We'll call this the upper locator group, and the index is 0001. Our other parts will be 0002, 0003, and so on. Same logic for the bottom. Okay, this way we finish one part. Next, let's look at the next part, index 0002. We can see between 1 and 2, they are a mirror relationship. If I duplicate 0001 and change its x-axis scale to -1, then we'll see it's already at the position we want. But there's a problem here. I really don't want to have any negative values in my upper group scale. Why? It's because many features in Maya rigging don't actually support negative scale values. When we set the scale to a negative value, it can cause some unexpected problems. So here, if we don't have a special reason, we should avoid changing our scale as much as possible. But here we do want this position because all the positions are correct now. So what do? First, before we do anything else, let's rename the nodes. We'll select the group we just duplicated. In Modify, find Search and Replace Names. We need to replace its name. We want to replace all 0001 with 0002. Here we'll select Hierarchy. This way, it will replace the names for this group and all its children. It will replace all of them. Click Apply. We can see all the 0001 have become 0002. Another thing to note here, we need to delete the 2 aim constraints we just created. Because when we duplicate the nodes from 0001 to 0002, these 2 duplicated aim constraints are no longer useful. So let's delete these unnecessary nodes. We'll need to recreate the aim constraints in a moment. After we've deleted them, next we'll take these 4 nodes under the group we just duplicated, the 2 0 groups and 2 locators, and press Shift+P on the keyboard to unparent them to the word level. To keep them in the same position, their translate and rotate will get some new values. The scale will too. But we need to change the scale back to the default value of 1, because we don't want negative scale values. Correspondingly, we need to take the group we just duplicated and change its scale back to 1 as well. Now look at these 4 locators. Their positions are already where we want them, and their scale hasn't changed at all. So now we can put these 4 back under the group we just duplicated as its children. This way the locator positions on this side are done. Let's do the same method for the lower part. Same thing, don't forget to rename. And we'll have to delete the aim constraints. Okay, this way all of our 0002 locators are also done. So same operation, let's make the aim constraints. Okay, we've finished the aim constraints. Next, we'll create the model groups and put our models in. This way, you see we finished 0001 and 0002. Next, we need to see how to get this group to the other 2 sections. We can see here, these 3 groups are actually in the same position, just with different angles. We know a full circle is 360 degrees. Since it's split into 3 groups, each group is 120 degrees apart. So we just need to rotate the corresponding group by 120 degrees, and it should get to the position we want. Let's duplicate it, and let's rotate it 120 degrees. We'll see it's now in the corresponding position. And same operation, we need to rename and delete the aim constraint. Same logic for the bottom. And then duplicate the other group. This way, look, all our locator positions are set up. Next, we use the same method to create the aim constraints for each group. Okay, so all our aim constraints are done. Next, we'll create the model groups and connect them with our locators. Okay, next we'll put our models into the corresponding groups. Okay, after we put all the models into their corresponding groups, let's move the controller now. We can see that all the parts have the connected behavior we wanted. And last but not least, let's do some cleanup. First are these locators under the green controller. We don't want animators to touch these locators, so we need to hide them. Select these locators, press Ctrl+H to hide them. Next are these locators for the base. Let's create a group for these locators, and this group we'll call it rig nodes. Then put it under master as its child, and hide this group as well, because we don't want animators to touch it. Next, all of these model groups, let's put them back under geometry as its children. And some of the model groups we had before. Since all these models are now in the new groups we created, these groups are empty, so we can delete these groups. Finally, the two locators we created to help us find positions, delete them. And don't forget to delete our display layer. This way, we've completed the Stewart platform rig. And that wraps up our introduction to constraints. I hope that through our explanations and exercises, we have a better, more comprehensive understanding of constraints, especially the function and purpose of the aim constraint, to help us to build a good foundation for our future exercises. See you in the next video.